Hello everyone, welcome back to my channel Explain Maths. Now in this video I am going to solve the exercise 2.2 of the chapter Polynomials. Now we will see first what is the relation between zeros and the coefficient of a polynomial. So zeros means for what value you will put in the variable such that the polynomial will give the value as 0. That is the zeros of the polynomial. So here I have taken a quadratic polynomial px equal to 2x square minus 8x plus 6. You have already studied in grade 8 and 9 how to factorize a quadratic polynomial, right? So let's factorize it. So here I can see 2 is the common factor. So I will take 2 common here. So it will become x square minus 4x plus 3, right? Then I can further factorize it as x square minus 3x minus x plus 3. I have used middle term splitting method. So again it will be 2. I have taken x common here. So it will be x minus 3. Here minus 1 common. So x minus 3. So it will be 2 times x minus 3 times x minus 1. Right. So this is the factorization. Now if you have to find the zeros of it, it means for what value of x this px will become 0. So now px when I factorize I have got this, right? So let's write it 2 times x minus 3 times x minus 1 equal to 0. So which further it means when this polynomial completely will become 0, when this complete will become 0, when either x minus 3 will become 0 or when x minus 1 will become 0, right? So if x minus 3 will become 0, so from here I can get the value of x as 3. And if x minus 1 will become 0, then from here I am getting the value of x as 1. So the zeros of the polynomial 2x square minus 8x plus 6 is 1 and 3, isn't it? For these two values of x, we can see this polynomial will become 0. You can check it. Put the value of x as 3 here and check. Again you put the value of x as 1 here and check. This polynomial px will give the value as 0. Okay, so these are the zeros of the given quadratic polynomial. So just now we have seen zeros of 2x square minus 8x plus 6 are 1 and 3. Now I am going to form a relation between the zeros and the coefficient of the polynomial. So first I am going to find the sum of the zeros. So zeros are 1 and 3. Sum will be 1 plus 3, isn't it? So 1 plus 3 will give me 4. Now 4 further I can write as minus of minus 8 by 2. Now what is minus of minus 8? It will be 8. 8 by 2 is 4. So without changing the value I am writing in this form. Now, what is minus 8? If you check this polynomial, minus 8 is nothing but the coefficient of x, isn't it? If you see here, minus 8 is the coefficient of x. And what is 2? 2 is the coefficient of x square. So, I am going to write sum of its zeros will be minus of coefficient of x by coefficient of x square. Now, next we will find product of its zeros. So, again zeros are 1 and 3. Product means we have to multiply, then only we will get a product. So product will be 1 into 3 which will give me 3. And 3 further I can write as 6 by 2. And if you see this polynomial 6 is the constant term and 2 is again the coefficient of x square. So you have to remember this. Sum of its zeros will always be minus of coefficient of x by coefficient of x square and product of its zeros are constant term by coefficient of x square. Okay. So we are going to use this while solving the exercise questions. So in general, if alpha and beta are the zeros of the quadratic polynomial px equal to ax square plus bx plus c, where a is not equal to 0, then we can say that x minus alpha and x minus beta are the factors of px. Now from where I can say that these are the factors if alpha and beta are the zeros? Just now I have given one example, right? I have taken this polynomial 2x square minus 8x plus 6 and we have seen that 1 and 3 were the zeros of this polynomial, isn't it? 1 and 3 were the zeros. So if 1 and 3 were the zeros, then what are the factors? X minus 1 and x minus 3 is the factor. So same way, if alpha and beta are the zeros, so x minus alpha and x minus beta will be the factors of the polynomial, isn't it? So I can write ax square plus bx plus c in the factorized form as k times x minus alpha into x minus beta, where k is a constant. Now further, if I multiply it, x minus alpha and x minus beta, I will get x square minus alpha plus beta x times x plus alpha beta, right? Now I'm going to multiply this k. So it will become kx square minus k times alpha plus beta x plus k alpha beta. Okay. Now I am going to compare this part and ax square plus bx plus c. I'm going to compare the coefficient on both LHS and RHS. So if I compare it, what I will get? First you see ax square and kx square. So from here I can write a will be equal to k, isn't it? Next, coefficient of x is, here is b. So b will be equal to minus of k times alpha plus beta, isn't it? Because coefficient of x is, here is b and here is minus of k times alpha plus beta. And just now I have seen the value of k is equal to a, right? So I'm going to replace it, k with a. So it will become minus a times alpha plus beta. And from here, if I have to find alpha plus beta, what it will become? I am going to transpose minus a to this side. So it will become b by minus a, which I can write in a standard form as minus b by a. So sum of the root is minus b by a. Next, again, if I compare the constant term, so I can write c equal to k times alpha beta. Further, k value is equal to a from here, isn't it? So I'll replace k with a. So alpha beta I will get as c by a. So from here I can see sum of the root is minus b by a and product of the root is c by a, where a, b and c are the coefficient of x square, x and c is the constant term, right? So you have to remember it. If you have to find the sum of the root of the equation, it is minus b by a and product of the root is c by a. Clear? So now I have given the summary here. If alpha and beta are the zeros of the quadratic polynomial, then sum of the root will be equal to minus of b by a, where b is the coefficient of x and a is the coefficient of x square, and product of the zeros will be c by a, where c is the constant term and a is the coefficient of x square. Second point is a quadratic polynomial whose zeros are alpha and beta. If it is given like that, then the polynomial, if you have to form, it will be x square minus sum of the root times x plus product of the root. Okay. So these are the 2 points which you have to remember, because you are going to use it for solving the second exercise. Clear? So now I'm going to start with exercise 2.2, and question number 1 is find the zeros of the following quadratic polynomial and verify the relation between zeros and the coefficients, right? So zeros of the quadratic polynomial means you have to find the value for which this polynomial will become 0. So those values will be the zeros of the polynomial. And then you have to verify the relation. So just now we have seen the sum of the zeros is equal to minus of coefficient of x by coefficient of x square, and product of zeros are constant term divided by coefficient of x square. So once you get the zeros, you have to verify that relation. Okay. So I'm going to assume this quadratic polynomial as f of x. Okay. So I can write let f of x is equal to x square minus 2x minus 8. Now I'm going to factorize it. Okay, so I can factorize using the middle term method. So I have to find two numbers whose sum will give me minus 2 and product will give me minus 8. So it will be x square. 4 2s are 8, I know. So minus 4x plus 2x minus 8. And if I take x common, so it will become x minus 4 plus 2. Again x minus 4. So from here you will get x minus 4 times x plus 2. So this is the factorization. Now I am going to find the zeros of this polynomial. So for that, zeros means the value of this should give me as 0. And when it will give me 0? If x minus 4 is 0 or x plus 2 is 0. Isn't it? Now if x minus 4 is 0, from here I will get x equal to 4. And from here what I will get? The value of x as minus 2. If I transpose, I will get it minus 2. So 4 and minus 2 are the zeros of this polynomial. Zeros are 4 and minus 2. Now I have to check the relation also. So we know that sum of the zeros will be, I'm going to add it, which will give me 4 plus minus 2, isn't it? Zeros are 4 and minus 2. Sum means you have to add it. So 4 plus minus 2 will give me 2, isn't it? So this 2 further I can write it as 2 by 1. Yes, and from here if you can see, this 2 by 1 is nothing but the minus of coefficient of x by coefficient of x square. See, coefficient of x, if you see, it is minus 2 and coefficient of x square here is 1. So this I can further write as minus of minus 2 by 1, right? So this is minus of coefficient of x by coefficient of x square. Clear? Now next we have to see the product of the zeros. Now product of zeros means we have to multiply it. So 4 into minus 2, you will get minus 8. This further I can write as minus 8 by 1. And minus 8 is what? It is a constant term and 1 is the coefficient of x square. So here it is constant term divided by coefficient of x square. So my relation is also verified that sum of its zeros are minus times minus of coefficient of x by coefficient of x square, and product of zeros is constant term divided by coefficient of x square. So like this you have to find the zeros and then you have to verify the relation. Clear? So now I am moving to the second part of it. Now exercise 2.2, second question, 4s square minus 4s plus 1. So again I am going to assume this as f of s. F of s is equal to 4s square minus 4s plus 1. Now I am going to factorize it. So I can see this is a standard identity, 2s whole square minus 2 into 2s plus 1 whole square. So this I can write as 2s minus 1 whole square, which can be further written as 2s minus 1 times 2s minus 1. Now I have to find the zeros of this polynomial. It means fs should be equal to 0. And when it will become equal to 0? When 2s minus 1 equal to 0. Okay, both 2s minus 1 should be equal to 0. Is either this or this. So from here I will get the value of s as 1 by 2, and from here also I will get the value as 1 by 2. So here my zeros are 1 by 2 and 1 by 2. Okay, 1 by 2 and 1 by 2. So these are my zeros. Now I have to verify the relation. So sum of the zeros means 1 by 2 plus 1 by 2, which will give me 2 by 2, and 2 by 2 is 1. 1 further I can write as minus of minus 4 by 4, isn't it? And minus 4 is what? Coefficient of s, and 4 is coefficient of s square. So this further I can write it as minus times coefficient of s by coefficient of s square. Now next is product of zeros we have to find. So product of 0 means we have to multiply here. So 1 by 2 into 1 by 2, which will give me 1 by 4, right? And here you can see 1 is the constant term, you can check here, and 4 is the coefficient of s square. So this is my relation, constant term by coefficient of s square. Now I am moving to the next question. Now third question, 6x square minus 3 minus 7x. So again I am going to assume this as f of x equal to 6x square. I am rearranging it. First I am writing the coefficient of x and then the constant term. Now let's factorize it. So it will be 6x square minus 9x plus 2x minus 3. Now I have to take 3x common here. So 2x minus 3 plus 1 2x minus 3, which will be equal to 3x plus 1 into 2x minus 3. Now I have to find the zeros of this. So it means f of x should be equal to 0. And when it will become 0? If 3x plus 1 equal to 0 or 2x minus 3 will be equal to 0. Isn't it? So from here I will get x equal to minus of 1 by 3. And from here I will get x equal to 3 by 2. So my zeros are minus 1 by 3 and 3 by 2. Isn't it? These are the two zeros. Now I have to verify their relation. So sum of the zeros, let's add it. So minus 1 by 3 plus 3 by 2. So LCM is going to be 6. So here minus 2 plus 9, which will give me 7 by 6. Further I can write as minus of minus 7 by 6. And you can see minus 7 is the coefficient of x and 6 is the coefficient of x square. So it verifies the relation sum of the 0 equal to minus of coefficient of x by coefficient of x square. Next, product of zeros. So let's multiply minus 1 by 3 into 3 by 2, which will give me minus 3 by 6. And minus 3, if you see here, it is a constant term and 6 is the coefficient of x square. Isn't it? So we have verified the relation of sum of the zeros and the product of zeros. Okay. Now let's do the fourth question. Now the fourth question is 4u square plus 8u. Okay, now let's assume this as f of u, okay, which is equal to 4u square plus 8u. Now this polynomial does not have any constant term. So I can take 4u common over here. So I will be left with u plus 2. Now to get the zeros of this polynomial, it is possible f of u when it will become 0, when either u is 0 or u plus 2 equal to 0. And u plus 2 0 means the value of u will be minus 2. So from here I can get my zeros are 0 and minus 2. Now let's verify the relation. So sum of the zeros is 0 plus minus 2, which will give me minus 2. And this I can write as minus of 8 by 4, isn't it? And what is 8 here? 8 is the coefficient of u, isn't it? If you see here, 8 is the coefficient of u and 4 is the coefficient of u square. So it satisfies this relation, minus times coefficient of u by coefficient of u square. Now next find the product of zeros. So product of zeros means 0 into minus 2, which will give me 0, and this can be further written as 0 by 4, where 0 is the constant term, because here there is no constant term. So 0 is the constant term and 4 is the coefficient of u square. So it will be equal to constant term by coefficient of u square, isn't it? Now I will move to next part. Now fifth question, t square minus 15. So I am going to assume it as f of t is equal to t square minus 15. Now I'm going to factorize it. So t square minus, now how to split it? So we can write it as root of 15 whole square, isn't it? We know that root of 15 into root of 15, this is nothing but root of 15 into 15, which will give me the value as 15, right? So 15 I can write as root of 15 whole square. Now it is based on your identity a square minus b square, which gives a plus b and a minus b, isn't it? So this I can write it as t plus root of 15 and then t minus root of 15. Now to get the zeros of the polynomial, f of t should be equal to 0, and when it will equal to 0? When either t plus root 15 is 0 or t minus root 15 is equal to 0. So from here I will get the value of t as minus of root 15 or t as plus of root 15. So my zeros are, if you see, my zeros are minus of root of 15 and plus of root of 15. So these are my two zeros. Now let's verify the relation. So sum of the zeros will be equal to minus of root 15 plus root 15, which will give me the value as 0, isn't it? Which further I can write as 0 by 1. And what is 0 here? See, the coefficient of t is not there. It means coefficient of t is 0 divided by 1 is the coefficient of t square, isn't it? So it verifies minus of coefficient of t by coefficient of t square. T is 0. So minus times 0 will be 0 only. Next, we have to see the product of zeros, which is minus of root 15 into root 15, isn't it? And root 15 into root 15 will give me 15. So minus of 15, which further I can write as minus of 15 by 1. And now minus 15 is the constant term, which you can see from here. Minus 15 is the constant term and 1 is the coefficient of t square. So from there I can write product of zeros equal to constant term by coefficient of t square. Okay. So now I am left with only one of the question, sixth part. So let's do it. Now the last one is 3x square minus x minus 4. So I am going to assume f of x is equal to 3x square minus x minus 4. Now let's factorize it. So 3x square minus 4x plus 3x minus 4. So from here I will take x common. So it will be 3x minus 4 plus 1, 3x minus 4. So from after that I can write it as x plus 1 times 3x minus 4. Now I have to find the zeros of the polynomial. It means f of x should be equal to 0. And when it will be equal to 0? When x plus 1 equal to 0 or 3x minus 4 equal to 0. So the value of x is equal to minus 1 or x equal to 4 by 3. So zeros are minus 1 and 4 by 3. Now next I have to verify the relation. Sum of the zeros equal to minus 1 plus 4 by 3, which is equal to minus 3 plus 4 by 3 equal to 1 by 3, which can be written as minus of minus 1 by 3. And you can see minus 1 is what? Minus 1 is the coefficient of x and 3 is the coefficient of x square. So this is the relation. Now let's find the product of zeros. So product of zeros will be minus 1 into 4 by 3, which will give me minus 4 by 3. And minus 4 is constant term and 3 is the coefficient of x square. So this is the relation which I have verified, isn't it? So this is question number 1. Now we will do question number 2. Now question number 2. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. First one is 1 by 4 is sum of the zeros, minus 1 is the product of its zeros. So I am going to assume let alpha and beta are the zeros of the polynomial which I have taken as f of x. Okay. So in the question what it is given? Sum of the zeros means alpha plus beta is given as 1 by 4 and alpha into beta is given as minus 1. Now when you note sum of zeros and the product of zeros and you have to form a quadratic polynomial, then it will be in the form of x square minus sum of the zeros times x plus product of zeros. Now let's put all the values over here. So it will be x square minus 1 by 4x plus minus 1. Further, I can write it as x square minus x by 4 minus 1. Now let's take 4 as the LCM. So what it will become? 4x square minus x minus 4. Now if you do f of x equal to 0, then what will happen? 4x square minus x minus 4 by 4 equal to 0. And when you cross multiply, you will get 4x square minus x minus 4 equal to 0. So your quadratic polynomial is 4x square minus x minus 4. Okay. This is only your quadratic polynomial. Clear? So you have to remove this denominator. You should not write this denominator. So the quadratic polynomial is only the 4x square minus x minus 4. Now next part of this question. Now here sum of the zeros are given as root 2 and product of the zeros are given as 1 by 3. So again I'm assuming alpha and beta are the zeros of the polynomial. So alpha plus beta is root 2 and alpha into beta is 1 by 3. Now I have to form the quadratic polynomial. So f of x equal to x square minus alpha plus beta whole x plus alpha into beta. Now I have to put the values. So it will be x square minus root 2x plus 1 by 3. Now I have to take LCM again. So LCM will be 3. So it will become 3x square minus root 2x plus 1. So your polynomial will be 3x square minus root 2x plus 1. This is only your answer. Okay. Now moving to next question. Now here sum of the zeros are given as 0 and product of the zeros are given as root 5. So again I am going to assume let alpha and beta be the zeros of the polynomial. So sum of the zeros are 0 and product of the zeros are root 5, isn't it? Sum of zeros means alpha plus beta. Product of zeros means alpha into beta. And let's form a quadratic polynomial. So it is x square minus sum of the zeros times x plus product of zeros. So x square minus 0 into x plus root 5. So it will become x square. Now 0 multiplied by any number is 0. So it will be only x square plus root 5. So this is your quadratic polynomial. Now fourth question. Here sum of the zeros are given as 1 and product of the zeros are also given as 1. So again I am assuming alpha and beta are the zeros of the polynomial. So alpha plus beta is 1. Alpha into beta is also 1. So the quadratic polynomial will be x square minus alpha plus beta times x plus alpha into beta. So x square minus alpha plus beta is 1. So 1 into x is 1 plus 1. So this is your quadratic polynomial. Now next, here if you see sum of the zeros is given as minus 1 by 4 and product of the zeros are given as 1 by 4, right? So I will assume let alpha and beta are the zeros. So alpha plus beta is minus 1 by 4. Alpha into beta is 1 by 4. Now the quadratic polynomial will be x square minus sum of the zeros times x plus product of the zeros. So which is equal to x square minus 1 by 4 times x plus 1 by 4. Now take the LCM. So LCM will be 4. So 4x square minus and minus plus x plus 1. So your answer is going to be 4x square plus x plus 1. Okay, so this is the answer for the fifth part. Now moving to the last question of this question number 2. It is 4 comma 1. So again if I assume alpha and beta are the zeros of the polynomial. So sum of the zeros are 4, product of the zeros are 1. So the polynomial will be x square minus sum of the zeros times x plus product of zeros. So x square minus 4x plus 1. So this will be your quadratic polynomial. So that's all for today's class, and if you have any doubt in any of the question, you can write in the comment box. And if you did not subscribe to my channel till now, please subscribe it and share with your friends also. Thank you.